Hi, I'm Tom Reynolds. This is the second video in the correlation experiment. I'm here with Burt Jones, University of Southern California. He's my friend and the co-inventor of the rainbow sensor. What we thought we'd do is have Burt give you a kind of summary of what the status of oceanographic research is today and the kind of instruments that he uses all around the world.
Okay, one of our latest tools are these robotic gliders. These are vehicles that fly under the ocean. We call them gliders because, as you notice, there's no propeller. They go through the ocean and use buoyancy to change their motion either up or down, and with the wings that pushes them forward. These are equipped with instruments like the CTD over here that measures temperature and conductivity and salinity. Underneath are optical sensors that measure chlorophyll, which gives us a measure of the phytoplankton, optical backscatter, which gives us particulate matter. We use these instruments to put out in the ocean. They can stay out for about a month at a time and obtain measurements continuously. They can map a region in space. They telemetry the data back to us in real time via satellite and radio communications. And so we can obtain a long time and spatial record of changes that occur in the ocean regions.
Okay, Burt, if we were to take this to Bonaire, what would we get? And why are we using it?
We could, this could be very easily used in Bonaire. We could put it out, leave it out for about a month at a time, fly it around the island, obtain maps of temperature, salinity, the chlorophyll, the dissolved organic matter in the water, the particle concentration of the water.
Everything that the LMSP does, right?
Far more than the LMSP does.
Okay, so why don't we use it?
Primarily cost. This vehicle at the outset cost about $165,000 to buy. Operational costs are on the order to run it, and for personnel services for about a month is going to cost us between $30,000 and $40,000 of operational cost.
So the bottom line is, if the money was there, this would be the way to do it.
This would be one of the ways. This would give us one kind of information. Now that would be more stable.
I told you I was going to introduce you to the P-Bop. Gerardo, who is a graduate student from Columbia, and Burt are trying to figure out where to put the instruments. Apparently it's not that trivial. This is the mini Bop. All the instruments have been taken off this and they're being put on the P-Bop. P stands for plastic. The reason why we did this was to reduce shipping costs. So we can disassemble this thing. It's not glued yet, and we're going to glue it together in Bonaire so that if we need to do more instruments, it'll be there. Saves a fair amount of weight and saves quite a bit of shipping cost, but it is requiring a lot more work and trying to figure just exactly how to mount the instruments. There are other issues. This Bop, the mini Bop, is suspended from a rope on a boat, and so therefore it hangs down. It's pulled up and down from a boat. We can't do that on Bonaire because if we have a boat on top of the rainbow sensor, it will screw up the readings.
This is a downwelling irradiance sensor. This is a sensor we want to directly compare against the rainbow sensors because these are narrow wavelength downwelling irradiance sensors. So it's exactly what we're trying to measure with the rainbow sensor system, except these are calibrated very accurately. So this sensor has 7 wavelengths of data. As you can see, the 7 white spots, each of those inside there's a filter. So this gets the light coming from all directions as long as it has a downward component. So if it's coming in laterally like that or laterally like that, it still will measure the light. And so any light that's coming from any direction over top will be measured by this sensor.
A downwelling irradiance sensor, meaning it's measuring the light coming down from the top and from the side in 7 different wavelengths. And that's what this thing is designed to do. And it's a very important instrument. Burt, what does this thing cost?
I think this sensor is about this sensor by itself is about $7,000 or $8,000. We've got a matching sensor that goes on the bottom. This is the upwelling radiance sensor. This goes on the bottom. The difference between the one on the top and the one on the bottom is this measures light in a very narrow angle, and the reason for that is this is for correlating with data from satellites. The sensor is a 3-channel fluorescence sensor. It measures the fluorescence of chlorophyll, which is the pigments from phytoplankton in the water. There's a dissolved organic matter sensor, which measures fluorescence from obviously dissolved organic matter in the water. And then there's one for a specific group of phytoplankton, the cyanobacteria, and it's a phycoerythrin sensor. This sensor over here is also, measures optical backscatter, and optical backscatter is proportional to particle concentration in the water, so this measures the concentration of the particles. We measure it at 3 wavelengths, and by doing that it allows us to get an idea of what the particle size distribution of the particles is, because larger particles reflect light at different wavelengths than will smaller particles. This instrument is what we call a CTD. CTD stands for conductivity, temperature, and depth. So it measures the pressure in the water, which determines how far under the surface it is. It has a temperature probe that accurately measures the temperature of the water, and it has a conductivity probe that measures how well the water conducts electrical current, which is going to be a function of the salinity of the water. So it allows us to accurately measure the depth, the temperature, and the salinity that the package is at.
So okay, the plan is to assemble this, get all figured out, then disassemble and pack it.
Correct.
Take it to Bonaire and glue it together, and put it in the water.
And we'll obtain profiles next to the rainbow sensors, and that way we can accurately measure the properties that we are intending for the rainbow sensor to measure.